I solved AI on microcontrollers, but it's actually not how I solved AI on microcontrollers. It's how Daniel solved the AI on microcontrollers. And Daniel Paredes is AI and embedded software engineer who writes the blog BareMetallics. So you want to check out BareMetallics blog. You can see it there, BareMetallics.com. And it's also on, was it Substack that you have BareMetallics, Daniel?
Yeah, exactly.
Great. Yeah, it's a great blog. He started it, I think, last year, and there are a lot of good pieces up there, especially if you're interested in learning about how to do AI on small targets, which is coincidentally what we're going to be talking about today. So for those of you out there in the Discord world, welcome as well. Please, somebody over there, just shoot me a note and let me know if you are able to hear and see everything okay. Just want to make sure that the streams are all good, so there's everybody's able to maximize their time with us today. If 32-bit Saver, yep, you could give me a heads up over there. That'd be great. I'd really appreciate it. Great, can hear, can see the stream all right. Okay, very good. Well, I'm going to get into a couple of quick housekeeping items before we pass it off to Daniel. So Daniel's going to be taking us through a this is an old slide, but Daniel's going to be taking us through a his experience with AI and microcontrollers with a quick little presentation, and then we're going to get into some community discussion. So if you have questions of Daniel of how he got AI to work on a really small memory device, just general questions about how to get started. I've got a couple questions for him about what AI looks like in the actual workforce. Any of those questions, please feel free. There are a couple of different ways you can engage. So inside the chat channels of your respective platforms. So if you're in Discord and you see where Marvin just or 32-bit Savior just put a note, you can drop questions, comments, chats in there. Also feel free to discuss with each other while the conversation is going on. If you're in the Meetup platform, there's a bottom right, there's a chat button, the bottom right of your viewing window, and you can check that out, chat with each other, put questions in there, or just to the left of that, there's a questions tab, and you can put your questions in there too. So I'll field all of those questions. And if you're in the Meetup event as well, it might be easier in some cases to just come on stage. So if you have a very complex question, I might just invite you on stage. So be aware that there may be a call out for you to jump on stage, just so that we don't have to wait 25 seconds for you to type things. Just a couple quick items to note. If you're having problems with the stream today, you can use the same chat channels to contact me. So you either go at Brandon Lewis in the Meetup platform or at TechieLou in Discord, and just let me know what issue you're experiencing, and I'll do my best to try and help you out and make sure that you are able to get back involved in the event very quickly. A lot of times these things have to do with, either your browser settings, or in the case of Discord, using the Discord app instead of the web version. So a couple of tips that I would recommend are, number one, go to speedtest.net. If you are pulling down less than 5 megabits per second, you might have some issues with the stream. So if you are, try and switch networks. Number two, like I said, if you're in the Discord app, try to use the web app, not like the desktop app. There's some versioning issues, so try to do that. In the Meetup platform as well, in the bottom left, there's sort of a quick tips and tricks things called help, and that can hopefully get you going without having to involve me at all. So without further ado, I'm going to hand things off to Daniel, let him get going with his presentation, and then we'll dive right into some discussion after that. So Daniel, you got a screen share? Why don't you take it away?
Yeah, sure. It's trying to feel. Hello. Is it working? Right.
It's coming up. There you go. That's a beautiful slide.
Yeah. Hi everybody. My name is Daniel Paredes. I'm working in the embedded field as an embedded systems engineer, and also in some computer vision. So there, as it was mentioned, I have my blogs, BareMetallics.com. I just try to document my learning process in this embedded world. So maybe you might find some basic stuff, some so advanced like machine learning microcontroller, but just check it out. If you have some question or comments, just let me know. I would like to respond them. So I have some assumptions. So I will assume that you know the basic from convolutional neural networks and some basics of computer vision. At least you have the idea what convolution is. And the other thing is that you have also the basic understanding of embedded systems, like what's the difference between float and integer types, and also the main constraints in the embedded devices like power, memory. Okay, so I don't want to spend too much time discussing my project. I just present really quick my project, what I did, what I achieved, and then we will go straight to Q&A session. So because you will have more questions, so I would like to tackle all the questions, as many questions as possible, so everyone can learn the things that are more interested for you. So I think it's a win-win from both sides. So the project overview is the following. I have a small project. I just wanted to try computer vision on the embedded device. So I just chose a basic use case. For my use case, I have screws, like many types, black, big, short, and I just want to detect them and see how many of them are there, in which position. No? Then you can, for example, say, okay, I just want to detect the black one, so turn on the light when the gray one appears whatsoever. No? So, but the basic idea is that one. So this is my setup. So in order to develop this project, I had my microcontroller was based on the ESP32 with a camera. So you can see here on the right side, this is my small 3D structure with the camera on top. And also I need to, part of my setup was to have a constant lighting. So I bought a LED ring. So and to power this LED ring, I bought a Raspberry Pi Pico because I just wanted something with the chip with many I/O pins. So that's basically my setup. And also I was trying to do it, since it's embedded device, I was trying to do battery power. So I just bought a normal battery on 3.0 volts. I use some the Adafruit power boost to get 5 volts, and the rest is quite straightforward. Just connect the Raspberry Pi Pico with the LED ring and also the power boost through USB with the microcontroller. So that's the basic setup. So then now the biggest problem with embedded devices is we don't have too much flash and we don't have too much RAM memory. In this case, for the ESP32, we have 4 megabytes from flash and 8 megabytes from RAM. So in my case, the convolution network, the network I used was the YOLO. So YOLO comes from the company Ultralytics, I think it's called. Ultralytics. So they developed this network. So, and they offer many sizes. So it depends if you want to deploy on the cloud, if you want to deploy on the edge. So by default, they have 4 configurations, from the extra large, that is several megabytes, to the small one that's also megabytes. So as you can see here, the small ones is already 40 megabytes, but we have only 4 megabytes available. I mean, really, it's less than that because you have to think about, you may run Bluetooth or Wi-Fi whatsoever, so you need flash space for that application. Also, you don't want to use that 100% of the microcontroller, so actually you have less than probably 1 megabyte to use for the AI task. So that's the challenge. How do we run this YOLO on the microcontroller? So basically, we have to make the model 10 times smaller at least. So my approach was quite simple. So this is the original network from YOLO. So YOLO have 3 parts. The backbone that's focused on detect the features. The neck that's in charge. So what YOLO does is they focus on multi-scaling. So there are objects that are quite farther and quite closer. So if you want to detect a card that's closer, you use one scale. And if you want to detect a card that's a little farther, you use another scale. So, and at the end, we have the heads. That's basically the output where you get the probabilities. So, as you can see, it's quite complex network. In this network, you can see here there is another block. It's called C3. So inside this network, there are also small networks. So they are also quite complex. For example, we have the convolutional, plus BN and CILU layer. Also, we have a bottleneck and concat. So it's quite complex here, and depends on how complex your task is. This C3 layer can have many levels. So at the end, this network can be really, really complex with millions of parameters. So that's our constraint. So my idea was, okay, maybe I don't need to use each of this layer. So because I just want to focus on one use case. As you remember, I don't have many layers. I just focus. For me, for example, in my case, this object, the distance between the camera and the object is always the same. This distance is always the same. So I can simplify the model because that means I don't need this multi-layer approach to detect some objects. So what I did is that's more 20% understanding of the network itself, and 80% was just try and error. So I tried many configurations, many setups. So at the end, I end up with the following. So for example, I don't use this multi-layer approach, as I mentioned, because the distance between the camera and the objects is always constant. So I remove many layers from this multi-scale. And also, since my objects are quite simple, I don't need such a complex layer. So I remove some of them. And at the end, I end up with this small model, which is still YOLO, but really, really way more simple. So at the end, the model is 23 kilobytes. The smaller one was 17 megabytes, so it's more or less 1,000 times smaller. And you can see also the RAM consumption is around 70 kilobytes, so it's still we still have a lot of space to run Bluetooth or Wi-Fi or other applications. If you want to do some post-processing or pre-processing, you have enough space to do that. So at the end, the three main ideas was, okay, first, model simplification, because the use case is a simple use case, so you can simplify the model. You don't need all the complexity. Also, quantization. So YOLO usually floats to do the math. Floats is around 4 bytes. So in my case, you can see here, I just use the int8 data type. So that's another approach you can use to reduce your memory consumption. You don't need all these decimals or details to do the calculation. Of course, it's not to be as accurate as using floats, but depends on your use case. You have to try and check, okay, how much accuracy you're losing. Sometimes it's not that much. I don't know if the normal model is around 90%. When you just do the quantization, it's probably 85%. It's not that much. It depends on your use case. You have to try it. And also the other approach was the input reduction. Usually YOLO use, for example, images that are quite heavy. It can be many megabytes or many kilobytes. So in my case, it was a really small image from 96 times 96. So it wasn't that. So if the input is small, probably it means that all the network layers are also small. So that's the main 3 points I just wanted to share. So I will go straight to the QA. So if you have a specific question, just ask, and we can just start the discussion, okay?
Yeah, that's great. Thank you so much, Daniel. That's really good stuff, and honestly, a rapidly evolving field, and one that everybody's going to probably have to get a little bit more acquainted with as time goes on. It's really interesting. Of course, the reason that we wanted to talk to you and have you share, Daniel, was because you're talking about getting YOLO on microcontroller on a small footprint device. One thing that obviously we're going to encourage the community. Type in your questions, get your feedback. Let's get the discussion going here. The question that I first have is, you are doing this as a sort of a side project, but you also mentioned in the discussion beforehand with me when everybody else was offline that you've tried to do this at work a little bit, and you mentioned that it was really expensive. So what was the approach of doing this in a work environment, and what made it costly from their perspective?
Yeah. Right now, for the tiny ML, there are many use cases that are for fun. For example, my use case was for fun, but if you want to try a real use case, for example, medical devices, something like that, where you have the heart rate or body temperature, you want to measure that and detect some anomalies whatsoever. So first, your model have to be quite accurate. So and that means you need a lot of data, you need a lot of try and error, and also you have to think about the memory, the power consumption. So there are many things you have to think about it, and if you have small team, it's going to be quite hard because you need to develop the hardware, you need to develop the embedded software for for example, secure booting, Wi-Fi, Bluetooth layer, and also you need to develop the network or the machine learning algorithm. So there are many tasks, and usually in embedded work you work with small teams. So the issue at the end is if you have enough time to do all the things right? And on top, the other thing is you need the infrastructure to support your machine learning. So usually, if you do development in embedded devices, you use probably GitHub, GitLab, you have CI/CD, Jenkins. No? Either you pay for the service or you host internally. So that's the basics. But for machine learning, you need a platform to train your model on the regular basis. You need a platform to save your network or the way or the data sets. You need also a way, for example, if you develop the device on the field, the device has to keep up with the reality. Sometimes the reality changes. For example, if you think about the industry, you have a motor. The motor, not all the motors are the same. So if you train the model based on one model, when you are in the field, probably it's not the same model, but it's quite similar. So your device has to adapt to it. So it means you have to retrain a little bit your model. And the issue is how you are going to update your model. You have two options. The first one is you retrain on the model on the device, which is also hard, or you send data to some backend once per day whatsoever, and then you retrain your model in the cloud, and then you can do an update from your model. So you need this infrastructure to retrain the model to save that to get the data for the training. So it's not cheap. It takes a lot of time. It takes a lot of effort, and also takes some money because the cloud is not cheap. If you think about small teams.
So I'm curious how you landed on YOLO and ESP. ESP is a place that a lot of people are starting today, but then why that, and then why YOLO of all the things that are available right now.
It was more or less because I wanted to just try YOLO. I use it on the desktop, and the performance was quite nice, and also it gives you the option to actually know exactly where the object is. So you can say, okay, the object is on the left corner, it's on the right corner. You can also know how big that object is, and you can do it all in just one step. So either, for example, there are options in which you first detect some objects and then you do the classification. With YOLO, you just do it in one step. No? The other thing is, for me, wasn't I didn't want to sell a product, so for me it was more a learning process. I said, I will just want to know if I can run YOLO in the microcontroller,
Yeah, no, for sure. And actually, we've got a couple of folks. I think you've been introduced to them in the server who are doing different applications of embedded AI. One of them's Wafa here, and one thing that she asks is, why YOLO for microcontrollers? Have you tried TensorFlow, and do you think that might be more efficient? But have you worked with TensorFlow at all, or was YOLO just this really your first attempt?
Yeah, that's where we are combining two different things. YOLO is a network. The TensorFlow is the framework that you use to run YOLO. You can use TensorFlow. I could use my own C libraries to make the model run. So just don't confuse these two things.
Yeah, very good. So Asrafal is asking whether or not you use the Arduino IDE and if you were able to port it manually, or is it a ready-to-go library that you pulled down?
No. I just, since I myself a professional embedded engineer, I use my own tools. I use Python to compile the code and also to develop some scripts to train the model, and also to do the conversion from TensorFlow to C. And once I get this, I just use CMake to compile my C code and flash it.
That's great. So you've got obviously access to some tools that others may not have. So if you were recommending how somebody could get started with this, would Arduino be a good place to start, or like how would you recommend getting going with this?
Probably the best way to start or to try similar applications is just either you're using a Raspberry Pi with a camera, or using also the ESP32 with the camera. They also have support to Arduino. So I didn't use the Arduino libraries, but they offer that. So you can use it if you want.
You know, Wafa actually asked a question that ends up going, and actually, Wafa, I might ask you to just jump on here, and you too, Asrafal, because I think it might be easier for you to ask the questions yourself and start the discussion that way. But Asrafal asked here, or sorry, Wafa asked here something about Edge Impulse. So Edge Impulse is a framework that's commercialized, and you can get it for free, but it also helps with some of this development process. You were mentioning earlier that you have, that as a business, there's all this infrastructure that's needed. Have you used Edge Impulse, and what were you implementing at work? What was the stack there that you had to implement?
Yeah, I use it. I use once Edge Impulse, just try it. My issue, at least in Europe, the issue is always the data protection. So if you send your data to some third-party cloud, there is always the issue. Okay, is my data safe? Especially when the data centers are not in Europe. So that was basically the reason why I didn't use Edge Impulse. And also I said, okay, I know Python, I know computer vision, I know TensorFlow, so I can develop my own scripts. And also, the good thing about embedded machine learning on embedded devices is that data sets you use are not huge. So you can use a laptop to train your model in a couple of minutes, probably in seconds, it's already trained. Sometimes it's just faster to press enter with the script, wait a couple of seconds, and you got the result.
Yeah, I think it's the one part of this though that is really impressive is the fact that you're able to get. What do you have here? 27K. What was the overall final footprint that you had?
24K for the flash,
yeah,
and 67 for the RAM consumption.
Yeah, and as an embedded engineer, you know that a lot of what all of us are focused on is being able to optimize everything about the system. So, when you're getting down to 24K, you're talking about in a commercial context, which at some point I've imagined that you'll work on something in a commercial context, that you're saving tons of money there just based on being able to pick a SKU that has a smaller memory. So how much time, you walked through it, but how much time did this take you to sort of optimize this down? How long were you working on this?
Ooh, I think 3-4 days.
Okay.
Because it was a lot of try and error, and I got also bigger model, for example, 100K whatsoever, but when the inference at the time it requires to process, and that was also longer. So 1 second, 2 seconds. And so for me, wasn't good enough. So I wanted to do it faster. So that's why I said, okay, if I wanted to do it faster, I need a smaller network. That was the reason. Usually, as soon as I reach the speed I wanted, I stopped. But it takes a lot of try and error because this convolution networks is science and art. So it's a lot of try and error, so it takes time to do it.
So when you said 3 or 4 days, was that 3 to 4 solid days?
Yeah, exactly. Solid days.
Oh wow, okay. Asifal has another question here, and Asifal, if you want, you can just unmute your mic moving forward. But the question here is, are you sacrificing accuracy when you get the data set that small, when you're going down that small? So how accurate or what do you sacrifice?
Yeah, that's one point. Yeah, actually, you sacrifice on accuracy. The issue is always, the first question is how much accuracy do you need?
Mm-hmm.
So let's say if your requirements are, okay, I just need 80%, and your model has a higher accuracy than that, I mean, you don't need 100%. As long as you fulfill your requirements, you are okay.
Mm-hmm.
So
Yep.
that's the first thing. And also, it's if you have your data set, you have the training set, the validation set, and the test set, usually, no? So even though you have a good accuracy in the test set and the validation set and training set, it doesn't mean that your model is going to perform well in the real world. So that's another point you have to think about it.
Asifal, are you going to say something, or Wafa?
Is there any way to optimize that? Like I want to keep my not the data set, but actual model is small, and also the accuracy, like it's kind of 50-50. I want them both rather than sacrificing one for another.
If I got you correctly, you mean how can you
like I optimize both the storage things also and the accuracy. So I want to keep the sizes small, also the accuracy higher. So
the first, you can try a couple of techniques. If you have a neural network, it doesn't mean that each neuron helps you to improve your accuracy. Sometimes the weights are quite small, even sometimes zero. So there is this technique that's called pruning. So you have your model, and then you focus in this model. You check which weights are more relevant for your output, and the ones that are not relevant, you just take it out. So the model becomes smaller. And the other way to keep your accuracy high is if you train your model already using the data types you need. For example, if I want to keep the accuracy high, probably I should have trained my data with integers from the start. So that's the other way to keep them, to reduce the size of the model, and also to keep your accuracy relatively high.
So I'm interested in the process of pruning, right? So you said that a lot of this was trial and error, and it makes a lot of sense, right? I mean, and here, you're really focusing on getting a very optimized, final model. But when you're pruning, to Asifal's point, I'm trying to understand how you go about this incrementally so that you don't end up going way over. You're talking about how much time you're taking. When you're iterating, what's the process? How granular are you getting, and what are you doing in order to remove different neurons or different layers from the neural net?
Yeah, that's a good question. That's the magic of scripting. So usually when you have your validation set, just you train your model, you do the pruning, whatsoever, and then you test it with your validation test or data set whatsoever. You get some value, and if or some parameters, I don't know, accuracy, speed, whatsoever, and if you don't fulfill your requirements, yes, you can trigger the script again, or you can do basically a loop and checking for the most optimized model based on the parameters you change. So
okay, so you're really looking for optimization of parameters. You're not actually adding additional parameters necessarily each time.
No, if I'm quite confident in my model, say, okay, I try it to reduce as much possible the model size, the network itself, then I just tune some parameters.
Mm-hmm.
As I said, it's just some science and also it's art. So
Yeah. I guess if you were to try to do this in your job, like if you were going to go after this at work, one of the things that the PM would be really negative about would be, oh, I'm just going to trial and error this, right? They'd want you to be able to give them some sort of definitive time or definitive process. So you would just set something up, some process via scripting where you're just incrementally modifying your parameters until you got to an optimal.
Yeah, exactly. There are some services on the cloud that you can use it to retrain your model. And for example, MLflow, so you can do some experiments there. And you can do it locally, but if you have some cloud infrastructure or server, you can train the same model with different parameters on parallel, so you can speed up your training time. And also at the end, if you can speed up your training time, you don't waste too much money. So
yeah. So is this is MLflow you're referring to? This MLOps platform here that I'm sharing?
I cannot see what you're sharing. Yeah, exactly.
Okay. Yeah. No, this looks like something that could be pretty interesting. I'm going to go ahead and drop it down in the chat for those of you who are interested in looking at it's just MLOps, DevOps, MLOps.
A great tool is also how it's called. That's Hub. Okay. Wait. I just put in the chat. So you can also use that service. You don't have to develop the whole infrastructure. There you can upload your experiments. You can do some retraining. So you get a lot already done. So you can focus on your machine learning stuff and embed it. So here you have Git, you have CI/CD, you have machine learning experimentation, machine learning optimization, and other tools. And it's free, usually.
Yeah, I was just gonna say that most of these tools.
So there is another question. If I want to start with machine learning, the current awareness you have, what should? Oh, so if you mean machine learning in the embedded area, I will first focus on
both, like in the host computer and also embedded, like machine learning in general.
Yes, there are the basics. For example, you can learn about what's convolution, your linear algebra. You can learn about probabilities. I mean, if you really want to learn understand what's going on behind machine learning. So once you get the basics, you just focus on convolutional neural networks that are quite easy. Or you can focus also on other computer vision tasks that are also quite interesting, like optimization, pre-processing, post-processing techniques. So I will start with that.
So I have a question. You are using YOLO, right? But in the deployments, you have to convert it to a TF Lite for deployment in ESP or microcontroller. But YOLO and TF Lite have different architecture. How do you manage to convert it?
I have a script that does that. I can show you. This is my GitHub repository from the project. I just share in the chat if you want to check it yourself. So I know what you're saying. So basically, when I have a script that converts the model to C at the end, let me check if I can find it. Was here, but what I use is a Python script that does the magic for me. let me check if I can find it. My script's here. So basically, what I do is that's not. I don't know if I can find it right now, but in general, what I do is using Python to get the TensorFlow Lite model, and from this model extract the C array. So it's quite straightforward. If let me check if I can find the.
So you go from YOLO to C array directly. Don't need to go to TF Lite.
No, you go. No, wait. We are missing something. You get from the TensorFlow Lite, and then you can convert to TensorFlow
Lite to array.
Exactly, and the end you get an array.
Oh yeah, I get it.
So let's see this. Let me try once more. If it's okay for you. Okay. Convert more to the TensorFlow Lite. So basically, what I got here is here we have the quantization part. So where I get from float to integer, do some optimizations. So this is some configuration, but at the end I just convert to TensorFlow Lite. And once I got that, I converted it directly into C array. Where is that here? Convert to TensorFlow. Yeah, but as I said, once I got this, basically when you get the TensorFlow Lite model, you have that C array directly. You have to reformat. So let me check if I can find it here. Okay, here's prediction. TensorFlow. Well, I cannot find it right now, but it's basically that. So you got the model. Here it is. So I saved my model in the TensorFlow Lite format, and then I just reload it because I made this function quite general. So here's the model in the TensorFlow Lite format. And then to convert to C, it's just this function. So you have to reformat the file. So basically, you need to create a H file where you define, this is my model array, whatsoever. You also define how big your network is. And I can show you the file, but basically that's the function that makes that. So, and in the end, you will get something like this. Main. So here's the header file. So you get in this case my array is called model, and also you need the length. And the other file you will get with this script, you will get a CC file. So here's your network. So at the end, you get this beautiful C array. That's quite big. And at the bottom, you will get the length. So, and then you just copy directly on your application.
So for deploying this model on ESP, what does it require? What did you use? Did you use ESP IDF, for example, in ESP or something?
Yeah, I use I use TensorFlow to do it. I can show you. So if here, so I use TensorFlow Lite.
Okay.
There's some configuration, and at the end I got, if I'm not mistaken, here TensorFlow Lite micro interpreter. So that's all the libraries I need to deploy it. So and of course I need my model. And at the end, it's just you can get all this information how TensorFlow works in C. So that's quite.
Is this the only file you used for deployment?
Yeah, exactly. First I have to load the model, And once I load the model, I have to do some setup. For example, how big I want to, how much RAM I'm expecting to use. And also you have to define, for example, your which building blocks you use. For example, quantification, I use convolution, I use logistic. So you need to define also that. And once you get that, to use it, it's quite straightforward. So for example, you invoke the interpreter, and then this line does the magic. It's not that complicated one. That's the basic code for every TensorFlow application. You can do it
Is it
once.
real time detection? Is it real time detection?
Sorry,
is it a real time detection?
Yeah, what do you call real time? It depends on your requirements. For me, it was fast enough. For example, in my case, in my application, the inference time was around 300 milliseconds. So for me, it was real time in my case, given my requirements.
Awesome. Taj, did you have another question? I just saw that you added here that.
Can we run a YOLO 5 a model which is trained with the YOLO 5 or any other YOLO version into microcontroller by the help of TF Lite, like TF Lite micro library? Like even they are trained with different tools on in the host computer they are trained with YOLO, and in the microcontroller they are being running on TensorFlow.
You just need to convert it, I think. Convert it and you access it as TF Lite.
Exactly.
Right?
Okay, got it.
Yeah, as I said, I read in the chat, there is a tool called XXD. Yeah, you can use it directly. That's basically what I used from Python.
Yeah.
So, but yeah, if you use it on the terminal, you have to save it on the file. So I just call it from Python because I have all my training happens on Python. So it's better to just have everything on one place and just press enter and let it run.
All right, cool. Ali, you were on stage this whole time. I don't think you said anything, so I just wanted to make sure that you had an opportunity to ask a question or contribute, or so just say hi to Daniel before we move on. Oh, it looks like his or her microphone. No, it's open. So, all right, Ali. Well, if you have something to say, feel free to say.
Sure. If you have more questions, just write me an email. That's totally fine.
What's your email?
Yeah, I will just post in the chat. It's Daniel@BareMetallics.com. So I'll share my screen so everybody can see it.
Yeah, do you want to run through your blog real quick too, just so everybody can see where it is and
Okay, yeah. My blog is BareMetallics.com, and also I have a Substack. So as I hear you, it's my blog. You can check what my current projects, how I'm working, or what I develop. So basically, the projects are quite proud of. There's also another machine learning project, but that one is based on the STM32 and not the ESP. So if you are interested not using cameras, but some other sensors, like microphones whatsoever. Also, you can find from general information about how to write unit testing, the basics about some basics about microcontrollers, what are best practices. And in the other one, the Substack, you can find, it's not as detailed here, but you can find my projects with photos or my development process, which challenges I had, how I solved them, what I learned. So please subscribe to my Substack. That will help me a lot. No, I'll just share the posts. Also helps me.
Yeah, we're actually gonna integrate Daniel's blog into the devheads.io website. So it'll be an RSS feed. It'll be able to kick you back over here. We'll hopefully have that done in the next week or so. So you'll be able to, if you go to devheads.io, and we'll kick off the newsletter here shortly as well. By February, we'll include links to Daniel's blog there, and so you'll be able to check that out. The other thing is, and also wrapped up with my last question for Daniel is, so you can find Daniel in the Discord server if you go to discord.gg/devheads. He's at DeLeonPZ, and my question for you is, I was interested in how people come up with their handles. So where did that one come from? Your DeLeonPZ?
That's actually my name. I mean, I just got my name, the first two letters, and put everything together.
Okay. Fair enough. I've spent a lot of time racking my brain about handles in my life, so it's interesting.
Yeah, me too, the same. But at some point, I thought I just choose my name. This is one.
Right, it's easy enough.
Actually, I have a funny story. You mentioned to me that I know Daniel, but I didn't know what you're talking about until Noor told me that he is the post from the server. I didn't relate at all.
Yeah, it's interesting. It's interesting, like having the crossover between the identities that we use, because it's like, I'll be talking to people on email and they'll be like, oh wait, that's you. Or on LinkedIn, people reach out to me like, oh, that's you in the Discord server. So that's funny. Cool. All right. Well, thank you so much, Daniel. Awesome stuff. Really appreciate you coming on and then being part of a community that's also really appreciated on our end. So I'm going to jump back into the presentation on my side. So I just added Daniel to Daniel's blog to the list of resources that we have here. So this is a running list of community resources, and you can pull this out of the final slides that we upload. I'm going to integrate Daniel's slides into these slides, and so you'll have a nice resource moving forward. The next up is more meetups. So we've got a lot of meetups. DevEds is sort of a meetup-driven community. Tomorrow we've got one with Amesh, which is on more in the Seger debug land with real-time recording and visualization for optimized embedded development using System View. So if you want to tune in tomorrow at the 1500 UTC, you'll be able to check that out from Amesh. Then after that on Saturday, mastering BLDC motor control part 2 with Afuevu. That's the handle. So actually the first one of those was really awesome. You should definitely check that out if you're looking to get more into motor control applications and figure out some of the basics and getting started there. That's a great one. So I'm really excited for that one. Then on Tuesday, we've got, this is actually, I forgot to put Hemel's name in here. Practical guide for engineers, PCB fundamentals. So we're actually doing a bunch of demos right now in parallel, starting off with either Zephyr or Yocto based builds, and then moving more into the application. But on the hardware side, Hemel's also going to start helping us build out carrier boards and things like that that are application specific and help support those use cases. So this is a great place to start as we go down those paths, and you can follow along. And then, of course, as I just mentioned, we're doing a lot of stuff around operating system level things. So Ming is going to continue teaching us about how to build out your own custom Yocto BSP layer, which is awesome if you want to build an application that you can port really easily between hardware targets. So this is going to be a pretty awesome session, and that's next Thursday, a week from today. All of those are at 1500 UTC. So I think there's a couple other things here, partnerships and stuff. Yeah, more of these continuous improvement things, but we're kind of running out of time. But actually, we will stop here on the continuous improvement thing. Any feedback from anybody? Anybody want anything? Need anything? Have any recommendations or suggestions on how we can get better as a community? I'll ask you, Daniel, what did you think of today, and how do you think, what was missing? What do you think you would add? What do you think you would take away?
I really liked the experience to share the knowledge because when I was on the Discord side, I noticed that many people have the same issues with YOLO. They wanted to implement. I just share my knowledge, but I developed this project 1 year ago, but I didn't have an idea that there were more people actually trying the same thing, and that's why I like it from this community. So there are many things on parallel, and people can learn the basics and also some advanced topics like Zephyr or Yocto, right?
Yeah. So I think that's a really good point. As I mentioned, we're building out some projects and some demos that everybody can get involved with. Inside of the Discord and then subsequently the website and the rest of the community. If you want to participate, just sort of raise your hand or just jump right in. Frankly, I just created a Edge AI channel about a week or two ago. There's some updates coming to the server, some like pretty significant ones that I'll send a post out that sort of explains all of them in one fell swoop. But there's other people there, like Daniel said, who are working on similar things. So there may be opportunities to collab on projects and learn while you're going through it. So that's pretty much it for today. I really want to thank you, Daniel. It's awesome. Hopefully we can have you back, and then we'll definitely be following your blog for sure. And then if you have some availability tomorrow at 1500 UTC, come back. Same time, almost same place. If you go to the Meetup platform or in Discord, and you'll be able to see the login information for the Seger system view session with the mesh. So really appreciate it. Hope everybody has a great rest of your day, and we'll see you in the server.
Bye.
Take care. See you guys.